స్టార్టింగ్
అవసరం లేదు ఇక్కడ నుంచి ఎట్లా వాళ్ళకి ఎట్లా తెలుస్తుంది మళ్ళీ యూట్యూబ్లో ఇది డౌన్లోడ్ అయితే చేస్తాను.
Then seventh one is, so seventh one is temperature, then current. Current is measured in ampere. Ampere. Current can be measured in ampere. SI unit for current. Then eighth one is then after this current can measured in ampere represented by A. Then plane angle. Plane angle can measured in radian. It is measured in radian. Radian. Plane angle can be measured in radians. And ninth one is solid angle. Solid angle. It is measured in steradian. So steradian it is measured. Like this, all these are 9 fundamental quantities. They are independent. They won't depend on any other quantity. The other quantities may depend on these, but these quantities will not depend on other quantities. And second one is derived quantities. We said that the physical quantities are 2 types. First one is fundamental quantities and second one is derived quantities. We have learned about that. So first one is fundamental quantities. We have learned fundamental quantities and derived quantities. And I said that derived quantity, fundamental quantities are 2. Physical quantities are 2 types. Physical quantities are 2 types. First one we have learned about fundamental quantities. Fundamental quantities. Fundamental quantities we have learned about. And second one we should learn about derived quantities. Second one. What are derived quantities? We are going to learn. Derived quantities. Derived quantities. What are derived quantities? The quantities, those which are derived from the fundamental quantities are called derived quantities. The quantities, those which are derived from the fundamental quantities are called derived quantities. Since they are derived from the fundamental quantities, they are not independent. They depend on fundamental quantities. Derived quantities are derived from fundamental quantities. That's why these quantities are not independent. These quantities are not independent. Not independent. They are not independent. They are not independent. They depend on fundamental quantities. Depend on fundamental quantities. Fundamental quantities. Fundamental quantities. They depend on fundamental quantities. They depend on fundamental quantities. Then example for derived quantities. They depend on fundamental quantities. Example. Number 1. Example for fundamental quantity, derived quantities. Area. How area is a derived quantity? Then how does it depend on fundamental quantities? Area means, let us write Area means we will get area of rectangle. Area of rectangle. For example, what is area of rectangle? We'll learn this. Area of rectangle. Area of rectangle, how to get length into breadth. So for measuring the length, we should measure the length like this. And also breadth we should measure. Length is length, breadth is also length. Therefore, area is derived from one of the fundamental quantities, that is length. Length is length, breadth is also length. Suppose we want to measure the rectangle, we should measure the length. And also then breadth. Length is length, breadth is also length. Therefore, length is nothing but we should measure the major side of the rectangle is known as length. And length of the minor side is known as breadth. Anyhow, we are measuring 2 times length. Therefore, length is length, breadth is also length. Therefore, area is derived from one of the fundamental quantities, that is length. Therefore, area is not an independent quantity. It depends on fundamental quantities. It is derived from one of the fundamental quantities, that is length. It is derived from one of the fundamental quantities, that is length. Therefore, it is area is not, that is one of the fundamental quantities, that is length. Then, second example. Second example. Second example. Volume. How volume is a derived quantity? Let us write an equation for volume. Volume is nothing but length into breadth into height. Length into breadth into height. Therefore, volume is derived from one of the fundamental quantities, that is length. So here length is length, breadth is length, height is also a length. Therefore, L into B into H. Therefore, volume is derived from one of the fundamental quantities, that is length. Then third example, third example. Third example. Velocity. How velocity is a derived quantity? Then how does it depend on fundamental quantities? How does it depend on fundamental quantities? Velocity. Velocity. Velocity is nothing but distance by time. Velocity is nothing but distance by time. That is. Sorry. Velocity is nothing but distance by time. Velocity is nothing but distance by time. D by T. So distance is nothing but here. Distance is nothing but D is nothing but length. Time is also time, one of the fundamental quantities. Therefore, length is distance is nothing but length is a fundamental quantity. Time is also a fundamental quantity. Therefore, on the whole, this area is derived from one of the fundamental quantities, that is length. Area is derived from one of the fundamental quantities, that is length. If we go on right like this, all these derived quantities will depend on any one of the fundamental quantities, any two, any three, any few, or all. Therefore, these derived quantities are not the fundamental quantities, are not independent. They depend on fundamental quantities. All these derived quantities may depend on any one of the fundamental quantities, any two, any three, any few, or all. Therefore, they are not independent quantities. Next, systems of measurement. We are going to learn about systems of measurement. Systems of measurement. Systems of measurement. systems of measurement. Physical quantities can be measured in three systems. Measured in three systems. Number one, CGS. Number two, MKS. Number three, FPS systems. CGS, MKS, and FPS systems. So these are the three systems of measurement. Now, systems of measurement. Now, let us make a table here. System CGS. CGS stands for centimeter, gram, and second. Centimeter, gram, second. Means in CGS system, so this is a CGS system, centimeter. Once again, just can measured in centimeter, gram, and second. Means in CGS system, length can measured in centimeters, mass is measured in grams, time in seconds. This length, mass, and time are known as basic fundamental quantities. In CGS, there are three terms, CGS. So C is nothing but centimeter, G is gram, and S is second. Length, mass, and time are known as the basic fundamental quantities. Length, mass, and time are known as basic fundamental quantities. Basic fundamental quantities. So therefore, centimeter, gram, and second, they are measured in centimeter, gram, and second. Therefore, then centimeter, gram, and second. So time is measured, length is measured in centimeters, mass in grams, time in seconds. Then MKS system. In MKS system, second one. MKS system stands for M for meter, kilogram, and second. Meter, kilogram, and second. Means in MKS system, length get measured in meters, mass in kilograms, time in seconds. And third one is third FPS system. FPS means in FPS system, length is measured in foot. Length is measured in foot. Foot. And mass is measured in pounds. Foot, pound, seconds. FPS system, third one. FPS. So length is measured in foot. Mass is measured in pound. Time is measured in seconds. So foot, pound, second. Foot, pound, second. Means in FPS system, length is measured in foot, time is measured in pound, mass is measured in pound, and time can be measured in seconds. Time can be measured in seconds. So then let us make a note here. Then let us make a note. Note. And this question was given in so many competitive examinations. Which of the following is the standard unit for time? It was given second, minute, hour, day. Usually, we measure time in seconds, minutes, hour, day, month, and year also we measure. But either in Cgs system or MKS system or FPS system, time can be measured only in seconds. In international system or system international also, the time can be measured always in seconds. Therefore, second is the standard unit for time. Second is the standard unit for time. So that is about FPS system. Second is the standard unit for time. Then second is the standard unit. Then what about the minute, hour, day? They are nothing but derived units. All other units are known as derived units. Why? Because the minute, suppose 1 minute is 60 seconds. We can say minutes in seconds. Therefore, minute is derived unit. 1 hour also we can say in seconds. Therefore, hour is the derived unit. 1 hour is 60 minutes or 60 into 60 seconds. So, 1 day also we can say in seconds. 1 day, 24 hours into 60 into 60 seconds. That's all. Like that we can measure. All they are known as derived units. Therefore, second is the standard unit for time. And this question was given in so many competitive examinations. SSC, RRB, Group 1 and 2. What is the standard unit for time? Standard unit for time is second. Then second one is, who is known as the father of physical quantity? Second point it was given. Second one. Who is known as the father of physical quantities? Lord Kelvin is known as the father of physical quantities. Who is known as father of physical quantities? Lord Kelvin is known as the father of physical quantities. Why is he known as father of physical quantities? Why? Because he introduced the units for physical quantities. He introduced the units for physical quantities. According to Kelvin, we should measure all the physical quantities, whatever we face in our daily life. Then only we have clear understanding about the physical quantities. Then only we have the clear understanding about the physical quantities. Therefore, and he says that how much of work is done today, you should measure your own work. If you are unable to measure your work, then you don't know keen understanding regarding the nature of your job. That's why, and he says that how much of work is done today, you should measure your own work. That's why, on the name of whose honor, the name is named after unit for temperature. The unit for temperature is Kelvin. Kelvin is this scientist. So, he introduced the units for physical quantities and he tried to measure so many physical quantities and also introduced the units for physical quantities. Therefore, he is known as the father of physical quantities. This question was given in SSC and also Group 1 and 2. Who is known as the father of physical quantities? Lord Kelvin is known as father of physical quantities. Then third one, what are the basic fundamental quantities? The question was given. Basic fundamental quantities. Third point. We are going to learn about third point. Basic fundamental quantities. Length, mass, and time. These three are known as the basic fundamental quantities. Length, mass, and time are known as basic fundamental quantities. Why are they known as basic fundamental quantities? Why? Because they are the derived quantities will depend on all the fundamental quantities, but most of the derived quantities will depend on these three. Most of the 90 to 95% of the derived quantities will depend on these three only: length, mass, and time. Therefore, they are known as the basic fundamental quantities. Length, mass, and time are known as basic fundamental quantities. Why? Because most of the derived quantities will depend on these three only. 90 to 95% of the derived quantities will depend on length, mass, and time. Means the derived quantities will depend rarely on the remaining six fundamental quantities. Therefore, length, mass, and time are known as basic fundamental quantities. For example, in CGS, there are three terms. In CGS or MKS or FPS. CGS, there are three terms. MKS also three terms. FPS also three terms. Therefore, they are nothing but basic fundamental quantities. CGS basic fundamental quantities, MKS basic fundamental quantities, FPS also basic fundamental quantities. Therefore, the CGS, MKS, and FPS are known as that is length, mass, height, time are known as basic fundamental quantities. It was SSC, it was given also group to APPSC. So, which of the following are known as basic fundamental quantities? Length, mass, height, time are known as basic fundamental quantities. Then next one is which system is known as CGS system. CGS and MKS systems together are known as decimal systems. Decimal systems. Fourth point we are going to learn. CGS and MKS systems together are known as decimal systems. Which systems are known as decimal systems? It was given. Number one, CGS and MKS. These two systems are known as decimal systems. Why? Because they are easily convertible from one into the other in multiples of 10. Therefore, these two systems together are known as decimal systems. For example, 1 meter is 100 centimeters. 1 meter is 100 centimeters or 10 square centimeters. 100 or 10 square is the multiple of 10, easily convertible. Similarly, 2 meters is how many centimeters? 2 into 100. So easily, without putting a pen on the paper, we are able to see. Therefore, multiples of 10, they are easily convertible. At 200 centimeters is how many meters? 200 by 100. Multiplication or division with the help of the multiples of 10, we are able to convert into CGS into MKS or MKS into CGS. That's why these two systems are known as decimal systems. Similarly, 1 kg is 1000 grams. 1000 is the multiple of 10. 1 kg is 1000 grams or 10 to the power of 3 grams. Or 1000 or 10 to the power of 3 is the multiple of 10. Therefore, they are easily converted from one to the other. Therefore, CGS into MKS or MKS into CGS, we are able to convert. Therefore, these two systems are known as decimal systems. Just let me take some water, please. Okay, then CGS and MKS systems are known as decimal systems. Then fourth one is fifth point we are going to learn about. Fifth one. Then CGS and MKS systems we are learned about. Then FPS system is also known as FPS system is also known as FPS system is also known as British system. FPS system is also known as British system. Why is it known as British system? Why? Because it was introduced by British. Whenever they were ruling our India, this FPS system, whenever they were ruling our India, they introduced their respective systems. They reduce their respiratory systems in India. So that's why it is known as British system. Nowhere it is under use, but it's remained. We are today also we are using in India. Even nowadays also we are using. Suppose we go to any sports shop for buying anything, sports shop, any sports item like discus throw shot or dumbbell we use. So the shopkeeper says an unknown word he says. For example, 1 pound. This short put is £5 he says. Discus throw £7 he says. Dumbbell £4 he says. Then what is 1 pound? He won't give any clarity. Then 1 pound is how much? 1 pound is how much? 1 pound is 1 pound is equal to 453.6 grams. 453.6 grams, 1 pound is equal to 453.6 grams. 453.6 grams. That is 453.6 grams. That is 453.6 grams. 1 pound is. So therefore, that is also known as 1 pound is equal to 453.6 grams, or 1 kg is equal to 2.21 pounds. You can also say 1 kg is equal, for converting into 1 kg is equal to 2.21 pounds. So that is kg is more than pound, 2.21 pounds. 2.21 pounds, that is. Now let us learn another terminology. What is acceleration? Then what is 1 cubic feet? Let us learn first. 1 cubic feet. 60 point. Cubic feet. 1 cubic feet. Nothing but a cubical container of dimensions 1 feet length, 1 feet breadth, 1 feet height. Of dimensions 1 feet length, 1 feet breadth, and 1 feet height. A cubical container of dimensions 1 feet length 1 feet, breadth 1 feet, and also height also 1 feet. Cubical container of dimensions, each 1 feet length, 1 feet breadth, and 1 feet height. That is cubical container of dimensions, each 1 feet. Cubical container of dimensions, 1 feet length, 1 feet breadth, 1 feet height. It is known as 1 cubic feet. Cubical container of dimensions 1 feet each. So, and measure, leave your chappal and leave yourself, your feet. Your feet will be that. And feet came from foot. Foot is the singular word, and plural, feet is a plural. Plural form of foot is feet. So 1 feet length, 1 feet breadth, 1 feet height. Cubical container. Imagine, and that will be how much? If it is a hollow box, you take hollow box of 1 feet length, 1 feet breadth, 1 feet height. So that is 28.317 liters. 1 cubic feet is equal to, that is nothing but, that is nothing but 28 liters. That is nothing but 28 liters. 317, that is liters. 28.317 liters. 28. So by imagination it is less, but practically it will be more. If you take a cubical container of dimensions, 1 feet length, 1 feet width, 1 feet height, then that will be 28 liters and 370 milliliters. Now let us learn about next point. What is Cusick? Cusick. Cusick stands for cubic feet per second. That is cubic feet per second. Cubic feet. Feet per second. Cubic feet per second. And it is the unit for rate of flow of water. It is Cusick is nothing but full form is cubic feet per second, and it is the unit for rate of flow of water. Rate of flow of water. Rate of flow. Rate of flow of water. Cubic feet is nothing but. So suppose it is given in rain seasons regarding the reservoirs, particular reservoirs, say let it be Srisailam reservoir, inflow and outflow it is given. Inflow 1,30,000 cubic inflow it is given. Means in 1 second 1,30,000 cubic feet of water is getting into the reservoir. In 1 second, 1,30,000 cubic feet of water is getting into the reservoir. What is 1 cubic feet? A cubical container of dimensions 1 feet length, 1 feet breadth, 1 feet height, full of water. So that is 1 cubic feet, 1 feet length, 1 feet breadth, 1 feet height. If it is full of water, that is known as 1 cubic feet. Such cubical containers of water is getting into the reservoir every second 1,30,000. 1,30,000 cubic feet of water is getting into the reservoir. It is given, that is known as inflow. At what rate the water is getting into the reservoir, that is inflow. And also next column in the newspaper it is given inflow 1,30,000 cubic, then outflow 30,000 cubic. Outflow means when in 1 second 1,30,000 cubic feet of water is getting into the reservoir, same 1 second, then 30,000 cubic feet of water is going out of the reservoir. Then what is the net resultant in that? In 1 second, when 1,30,000 cubic feet of water is getting into the reservoir, same 1 second, then 30,000 cubic feet of water is going out of the reservoir in 1 second. Then what would be the next net result in the reservoir? 1,30,000 minus 30,000, nothing but 1 lakh. Means 1 lakh cubic feet of water is being reserved in the reservoir every second. So that's about rate of flow of water, QC. Now let us learn about what is TMC. We use in more frequently we read, especially in rain seasons, in newspapers we read regarding TMC. What is TMC? Just give it. TMC stands for T for 1,000. 1,000 million cubic feet. 1,000 million cubic feet. Million cubic feet. C for cubic feet. 1,000 million cubic feet. What this is numerically, this 1,000 is nothing but 1,000. That is 1,000 is nothing but 1,000. Million is nothing but 10 to the power of 6. So that is also written as, we can Numerically, we can write TMC, we can write 1000 is nothing but 1000, that is. Thousand million is nothing but 10 to the power of 6. 1000 million and cubic feet, that is nothing but cubic feet. 1000 million cubic feet. 1000 is also written as 100 into 10 to the power of 4, 7, we can write this 100 into 10 to the power of 7. Why? Because 100 into 10 to the power of 7. That is nothing but 1000 into 10 to the power of 6. That is cubic feet. Cubic feet. That is also written as 1000 is also written as 100 into 10 to the power of 7 also we can write. So there is cubic feet we can write as it is. Cubic feet. So that is also written as 100 is also known as 100 into 10 to the power of 7. 10 to the power of 7 is nothing but 1 crore. If 1 crore cubic feet of water, 1 crore, that is beside that 100 is there. If 100 crore of cubic feet of water is present, stored in a reservoir, then it is known as 1 TMC. If 100 crore of cubic feet of water stored in the reservoir, then it is known as 1 TMC. 100 crore of cubic feet of water stored in the reservoir, then it is known as 1 TMC. So that is, it is the unit for capacity or storage, volume or capacity, unit for volume or capacity. TMC is the unit for volume or capacity. TMC is the unit for volume or capacity. Volume or capacity. Unit for volume or capacity. For example, Srisailam Reservoir, it is 216 TMC it is given. Means in Srisailam Reservoir, 216 TMC of water can be stored. And but present it is around 140 TMC. Then Nagarjuna Sagar full capacity is 312 TMC. At present, approximately 180 TMC of water. So it is nothing but unit for capacity or volume. Similarly, in Hyderabad, around about 1 crore people are residing in Hyderabad. So throughout the year, they are supplying the water. Actually, day by day or alternate days they are supplying. So day by day or alternate days they are supplying. In alternate days they are supplying how much water? Just 20 TMC of water throughout the year. 20 TMC of water is more than enough for 1 crore people. That is for 1 year. Maybe even the alternate days it is sufficient for drinking water and also domestic purpose we have. So TMC is the largest unit for volume. Similarly, so that is we know that what is Mission Bhagiratha? Mission Bhagiratha is the program launched by state government of Telangana, and that is about Mission Bhagiratha. Then how much of water is there is supply of water to the rural areas? Just 84 TMC of water they are supplying. It's more than enough for supplying our whole rural area, rural villages for drinking water. 84 TMC. So what is Mission Bhagir, Mission Kakatiya? Repair of the tanks and tanks in Telangana. 45,532 tanks are found in Telangana, and at an average every year 20% they repaired. So almost all not 30 to 40% they finish the program. So if everything is finished in Telangana, all these 45,532 tanks are repeated in Telangana. In addition to which 155 TMC of water can be stored in all these 45,532 tanks. So more 155 TMC of water can be stored. And what I mean to say is TMC is the unit for volume or capacity. Now we are going to learn about another terminology. What is acceleration? Acceleration. Acceleration is represented by A. What is acceleration? Acceleration is nothing but the rate of change in velocity of the object is known as its acceleration. Acceleration is nothing but the rate of change in velocity. Change in velocity is known as acceleration. The rate at which the object is changing its velocity is known as acceleration. So that is nothing but suppose at which rate the object is changing its velocity. That is also written as change in velocity by time. Suppose whenever we are going on the pipe, our speedometer first it was at 20. Yet after few seconds, let it turns to 50. Means there is change in velocity. The rate at which the object is changing its velocity is known as acceleration. So the rate of change in velocity of the object is known as its acceleration. Rate of change in velocity of the object is known as acceleration. So that is nothing but acceleration is represented by A, no? So that is A is equal to that is change in velocity by time. Change in velocity by time. Whole by time. We should divide by time. Time. So that is change in velocity by time. When do we change? Say that there is change in velocity. When do we say that is there is change in velocity? Change in velocity. So that is change in velocity is nothing but final velocity minus initial velocity. Final velocity represented by V minus initial velocity. Final velocity minus initial velocity. That is initial velocity. Final velocity is nothing but V and initial velocity can be represented by U. So by time t, that is change in velocity by time, no? Change in velocity by time. Or by it is measured that is time. So that is acceleration A is equal to, we can also write A is equal to V minus U by T. Acceleration. That is A is equal to V minus U by T. Acceleration A is equal to V minus U by T. Therefore, acceleration A is equal to V minus U by T. V minus U by T. V minus U. This is about acceleration. So then what are the units for acceleration? Suppose an object is uh, starting from rest. What is the initial velocity of an object which is starting from rest? The initial velocity of the object which is starting from rest is 0. Initial velocity can be represented by 0. U is equal to 0. Initial velocity is represented by U. Final velocity is represented by V. If any object is starting from rest, its initial velocity is 0. Suppose an object is starting from rest, that means whose initial velocity is 0. After 1 second, let its velocity is 2 meter per second. After more 1 second, 4 meter per second. After more 1 second, its velocity is 6 meter per second. Therefore, its velocity has been increased. at which rate each and every second 2 meter per second for every second. Then what is the acceleration produced here? The acceleration produced here is acceleration A is equal to V that is acceleration. Here 2 meter per second for every second, that is 2 meter per second. That is for every second. 2 meter per second, that is for every second. Therefore, acceleration A is equal to 2 meter per second square. A is equal to 2 meter per second square. 2 meter per second square. This is the acceleration produced in the object. 2 meter per second square is the acceleration produced in the object. 2 meter per second square. So this is the unit for acceleration. Then MKS unit will be this CGS unit. Then unit for acceleration will be, that is CGS unit. MKS unit is meter per second square. Then CGS unit will be units. That is units. CGS, that is centimeter per second square. Then MKS unit will be meter per second square. MKS unit. Nothing but meter per second square. So this is it. Now let us make a note here. If any object is starting from rest, if any object is starting from rest, then its initial velocity is 0. If any object is starting from rest, if any our bike or car or bus or anything starts from rest, then its initial velocity will be 0. Then what is the final velocity of the object which is coming to rest? The final velocity of the object which is coming to rest is 0. That is v is equal to 0. Suppose whenever we are going on the bike, something is coming across our bike. Then if we apply the brake, then our bike suppose let it be stopped. By the time our bike is stopped, the final speedometer turns to 0. So why? Because it is becoming to 0. So it is coming to rest, therefore its final velocity will be 0. So therefore, the final velocity of the object which is coming to rest is 0. Therefore, if any object is starting from rest, then its initial velocity is 0. And final velocity of the object which is coming to rest is 0. If any object is coming to rest, then its final velocity will be 0. Then what is the simple meaning of object is under acceleration? Third point, let us start. What is the simple meaning of object is under acceleration? What is the simple meaning of object is under acceleration? The simple meaning of object is under acceleration means its velocity is going on changing. Its velocity is going on changing. Its velocity is going on changing. Velocity is going on changing. So the rate at which the object is changing its velocity is known as acceleration. Change in velocity means maybe increase in velocity or decrease in velocity. Both the cases are said to be acceleration. But increase in velocity is said to be positive acceleration. Decrease in velocity is said to be negative acceleration. Both the cases are said to be acceleration. Suppose whenever we are going on the bike, our speedometer, so when we start from rest, 0, 10, 20, 30. Whenever start our bike and applying the first gear, then we are raising. Speedometer goes on. Second gear we go on next. The speedometer changes from 0 to 10, 20, 30, 40 length. Its velocity is increased. The rate at which the velocity is increased is known as acceleration. So that is nothing but positive acceleration. The rate at which the object is going on increasing its velocity is known as positive acceleration. Then suppose whenever it is going with a 50 or 60 speed like that, we are applying the brake. What happens? The speedometer falls. That is 60, 50, 40, 30 and so on. That is also acceleration. Now it is negative acceleration. The rate at which the velocity has been increased is known as positive acceleration. The velocity at which the object is decreasing its velocity is known as negative acceleration. Both the cases are said to be positive, that is acceleration. First case is positive acceleration And second case is negative acceleration. But positive acceleration can be represented by plus a, and negative acceleration can be represented by minus a. That is r plus a is represented by. And negative acceleration can be represented by minus a. This negative acceleration is also known as retardation or deceleration. Retardation or deceleration. Now, what is the acceleration produced in the object which is moving with uniform velocity? Uniform velocity means no change in velocity. Therefore, acceleration is zero. Means to be under acceleration, the object should change its velocity. Whenever it is moving with uniform velocity means constant velocity, no change in velocity. Is there any acceleration? No acceleration. Zero acceleration. Therefore, zero acceleration. It's nothing but zero acceleration. Therefore, whenever it is going with uniform velocity, no change in velocity, no acceleration, zero acceleration. Otherwise, we are going on the bike. Let it be on straight road, our bike is going on. First, the speedometer was seen on 60. After 5 or 6 seconds also, still it is standing on 60. After 10 or 15 seconds also, still it is standing on 60. 20, 25 seconds also standing on 60. Then what is the acceleration? We know that acceleration A is equal to V minus U by T. Acceleration A is equal to V minus A is equal to V minus U by T. V minus U by T. What is the final velocities? 60. Initial velocity also 60. 60 minus 60 is how much? 0. 0 by time, any time. 1 second, 2 seconds, 3 seconds. 0 by something is always 0. Therefore, the acceleration produced in the object which is moving with uniform velocity is 0. It was given group 1, group 2, and also SSC, RRB it was given. What is the acceleration produced in the object which is moving with uniform velocity? If any object is moving with uniform velocity, then acceleration produced will be 0. 0 acceleration. So then that is about acceleration. Then let us learn about acceleration due to gravity. Acceleration due to gravity. And just before that, let us learn about what is freely falling object. Freely falling object. Falling object. Freely falling object. If any object is falling to the ground without applying any external force, then it is known as freely falling object. If any object is falling to the ground without applying any external force, then it is known as freely falling object. It is falling to the ground without applying any external force, then it is known as a freely falling object. Then that is known as freely falling object. If any object is falling to the ground without applying any external force, then it is known as freely falling object like this. If it is falling. So then what is the initial velocity of freely falling object is? The initial velocity of freely falling object is 0. Initial velocity of freely falling object is 0. That is u is equal to 0. Let after 1 second, after 1 second, after 1 second, let its velocities after 1 second, what would be the velocity? If its initial velocity is 0, after 1 second, its velocity will be 9.8 meter per second. 9.8 meter per second. And each and every second, the velocity of freely falling object, and after 1 second, its velocity will be 9.8 meter per second. 8 meter per second. And after more 1 second, its velocity will be after 1 second, after more 1 second, its velocity will be 19.6 meter per second. 6 meter per second. After more 1 second, its velocity will be 29.4 meter per second. 29.4 meter per second. .4 meter per second. So that means its velocity has been increased each and every second. Here, that is 0 to 9.8 is 9.8 meter per second increase, next 9.8 is increased, next 9.8. Therefore, the acceleration produced here is 9.8 meter per second is increased every second. 9.8 meter per second is increased every second. So therefore, it is under acceleration. So 9.8 meter per second increase every second. Therefore, the acceleration will be 9.8 meter per second for every second. Therefore, and why is it is increased? Why the velocity of object is increased each and every second? Why? Because Earth is attracting. Earth's attraction force is also known as gravitational force. Earth's attraction force is also known as gravitational force. Gravitational force simply we call it as gravity. The velocity can be increased means it is under acceleration. It is under acceleration due to gravity. Therefore, acceleration due to gravity. Acceleration due to gravity represented by small z. That's why small z is equal to, we take it as, small z is equal to, we take it as 9.8 meter per second square. 9.8 meter per second square. 9. That is small z is equal. Why do we take small z is equal to 9.8 meter per second square? That is 9.8 meter per second square. 9.8 meter per second square. Why? Because the initial velocity of any freely falling object will be 0. Exactly after 1 second, its velocity will be 9.8 meter per second. Or after 1 more second, more 9.8 meter per second is increased. Therefore, the velocity of freely falling object can be increased. Why does it increase? Because of gravity. It can be increased because of gravity. Gravity is, if its velocity can be increased means it is under acceleration. It is under acceleration due to gravity. So therefore, acceleration due to gravity, at which rate each and every second 9.8 meter per second, that is due to gravity. It is under acceleration means it is centimeter acceleration. That is because of gravity. Acceleration due to gravity. Therefore, small z is equal to 9.8 meter per second square meter. Small z is equal to 9.8 meter per second square. So therefore, that is acceleration. Now let us make a note here. Now, small z is about 9.8 meter per second square. And different various questions based on this. It was given. It was given in Group 1, Sub-Inspector of Police, and also it was given in RRB. Two objects of different mass, say 1 kg and 10 kg. One is 1 kg, the other is 10 kg. 10 kg. Both are dropped from same height simultaneously. It is given that one is 1 kg, the other is 10 kg. Then both are dropped from same height simultaneously. Then which of these two will reach the maximum height? So which of these two will reach the first? One is 1 kg, the other is 10 kg. Both are dropped from same height simultaneously. Then which of these two will reach the ground first? So some people will answer in offline 10 kg reaches first. Some other people will say that 1 kg reaches first. So, but But the answer is that both will reach the ground at a time. If you want to conduct, you take your pen and cap, try to draw from the same height, pen and cap. So your pen and your cap, your pen cap. So try to draw from same height. Surprisingly, both will reach the ground at a time. You can draw from 1 meter, 2 meters, or 10 meters height. Doesn't make it matter. Or you take small pebble and large, just little bit stone, little big stone, this much of stone and small pebble. Try to drop from same height. Both will reach the ground at a time, irrespective of the mass. And this was experimentally proven by Galileo. Not now, in 16th century itself, he proved that. So, and he conducted the experiment in presence of the public, general public, and on the interest of the public, he conducted this experiment. So, he dropped two different mass objects from the top of the three-story building. Three-story building means approximately 10 meters height. So, he made to drop from the top of the three-story building, top of the three-story. So, top of the three-story building. One is 1 pound, the other is 100 pounds. So 1 pound is nothing but 453.6 grams, little less than half kg. The other is 100 pounds. And he made to drop from the top of the three-story building. Then which of these two will reach the ground first? He answered. So then this question is raised in presence of the public, and the experiment was conducted in presence of the public and on the interest of the public. Galileo asked the question, which of these two will reach the ground first? And both are iron spheres, solid spheres, means without gap inside, without emptiness inside, are known as solid spheres. And it made to drop from the top of the three-story building. So, we put the question to the general public, which of these two will reach the ground first? Most of the people answered 100 pounds, reach first. And few clever people also answered 1 pound. Why? Because if there is a running competition between a fat and lean fellow, who will be the winner? Definitely, this lean fellow will be the winner. That's why they answered 1 pound reaches first. They answered. But whenever he conducted this experiment, surprisingly, both are reached the ground at a time. Both are able to reach at a time means so, and this experiment was conducted by several times, repeated for several times, many times repeated. And also he chose the people, he suggests the people, you can also conduct the experiment, take a large stone and small people, try to drop from the same height. He suggested the people. That's why Greeks will contribute a lot to for the development of science and technology. Always they think, they conduct more experiments. And also they think what, why, when, how. They think, they question themselves. That's why they contributed a lot for the development of science and technology. Nowadays, in science, that is physics, chemistry, biological science, maximum terminology is taken from Greek. It's not from English. It's from Greek. Either physics, chemistry, botany, zoology, any mathematics, any branch of engineering, or any branch of science, and any branch of medicine. All the terminology was taken. Most of the terminology was taken from Greek language. Therefore, so if we drop therefore 1 kg and 10 kg, which of these two will ground the first? Both will reach. Why? Because both the velocities will increase at the same rate, 1 kg or 10 kg. Both will reach the ground at a time. Why? Because the velocity of both the objects will be increased at the same rate. Each and every second, 9.8 meter per second is increased. Each and every second, the velocity of object can be increased by 9.8 meter per second for every second, and irrespective of the mass. Therefore, both the objects increase the ground at a time, irrespective of the mass. Both the objects will reach the ground at a time, irrespective of the mass. Therefore, both 1 kg and 10 kg will reach. Similarly, if the object is projected up, what happens if an object is projected up with certain velocity? Suppose let it be 40 meter per second if it is projected. 40 meter per second if it is projected. 40 meter per second. What happens? While it is going up, its velocity decreases each and every second. 9.8 meter per second it can be decreased. Each and every second, the velocity of object can be decreased by 9.8 meter per second for every second. Suppose whenever it is projected up with 40 meter per second, next its velocity will be 40 minus 9.8. How much? 40 minus 9.8 is nothing but approximately 10 it decreases by. 40 minus 9.8 or approximately 10. 40 minus 10, it will be 30. After more 1 second, 30 minus, then 10, 9.8 or 10. That is 20. It becomes next second 10, next second 0. That's it. Then after 0, can it go up? It won't go up. It falls to the ground. When it falls to the ground, what happens? Its velocity increases. At which rate? At the same rate. Whatever the velocity by which it was decreased, now it can be increased at the same rate. Next second 0 to 9.8 or 10. Next second 20. Next second 30. Next second 40. What do we understand here? Whatever the velocity by which it was projected up, the object can reach with the same velocity. That's what we learned here. It is projected with velocity u and u, that is the initial velocity. If it reaches the ground with velocity v, then both will reach the ground. Whatever the velocity by which it is projected up, the object is projected up. The object can reach with the same velocity. If it is projected with velocity u, if it reaches with velocity v, both are same. You project with 40 meter per second, the object reaches the same 40 meter per second. The question was given in RRB. Suppose an object is projected with 40 meter per second, then what is the velocity by which the object can reach the ground? Same 40 meter per second. Not only 40, you project it with 50 meter per second, again the object reaches with 50 meter per second. If projected with 60 meter per second, it can reach with same 60 meter per second. So now next point, let us learn about, suppose if 1 kg and 10 kg are dropped from same height, which of these two objects of different mass, 1 kg and 10 kg, reached at a time the ground. Galileo also conducted this experiment in 16th century AD. It dropped from the top of the 3-story building 1 pound and 100 pounds iron stones, iron solid spheres. Both are reached at a time. Otherwise, if we take another example, abnormal example, different kind of example. Let us take a feather and coin. Let us take feather and coin. We are taking feather and coin. We are taking coin. Are dropped from same height simultaneously, then which of these two will reach the ground first? So definitely coin reaches first, but feather reaches slowly. But according to our basic fundamental principle, both should reach the ground at a time. But here, coin reaches first, but the feather reaches slowly. Why can't the feather reach along with the coin? Why? Because of air resistance. The air will resist the motion of the object. Air will try to stop the feather. Air will try to stop the feather. Air resists it. So because of air resistance, the feather reaches. If it is possible, remove all the air, then both will reach the ground at a time. Both will reach the ground at a time. And the concept was brought up by Galileo. And also it said, if it is possible, remove all the air, then drop both the coin and feather will reach the ground at a time, irrespective of the mass. Feather and coin will reach the ground at a time, irrespective of the mass. I said. He not only said, but also proved in practical. So, why? Because science is not imagination. Science should be proved in the laboratory. He proved himself. And he took a glass tube of length approximately 10 meters and was closed at one end and opened at the other. At the closed end, he put a feather and coin. So it was glass tube of length approximately 10 meters. Glass tube. A glass tube of length 10 meters. 10 meters. It took a glass tube of length 10 meters which was closed at one end and opened at the other end. Closed at one end and opened at the other. Glass tube. So I'm unable to draw here, please. So, okay. And it was closed at one end and opened at the other end. So from the bottom it was closed. At the bottom, it was closed at the bottom. So that is closed at one end and opened at the other end. Closed at one end and opened at the other end. So that is about let it be. So it took a glass tube of length approximately 10 meters and was closed at one end and opened at the other end. From the and kept in vertical position and on the top of the closed end, it kept a feather and coin inside the glass tube and he made an arrangement. He made an arrangement like this. So then closed at one end and opened at the other end. Opened at the other end like this. One end and opened at the other end. So then at the closed end, he kept a feather and coin, and on which he kept a feather and coin. From the bottom of the glass tube, he removed all the air from the bottom of the glass tube with the help of evacuator. Then it was closed. The bottom is closed after removing all the air. Before, at the top, on the same lever, he kept a feather and coin. Now, after removing all the air, the bottom was closed. Then we pulled the lever. We pulled the lever like this. Pulled the lever like this. This lever on which we placed both the feather and coin here. Feather and coin were placed. Then we pulled this lever like this. Pulled. Then, surprisingly, both the feather and coin are reached the ground at a time, irrespective of the mass. Both the feather and coin have reached the ground irrespective of the mass. This was also given group 1, group 2, and also sub-inspector of police was given. In a vacuum tube, a feather and coin are dropped from same height simultaneously. Then which of these two will reach the ground first? It was given. So both will reach the ground at a time with respect of the mass. So then why? Because there is no air inside, no air resistance. But outside, air will resist the motion of the object. So therefore, the air is resisting the motion of the object. So, but inside the vacuum tube, there is no air resistance. Therefore, feather can also reach along with the point, along with the point. Therefore, so and this is the end of this chapter, and this basics and fundamentals will be more here. Now, let us start the other topic in next class. And today, just I'm unable to write properly. This is the new system for me. So then system is not properly here. That system is like that. Just to, I will try to improve my handwriting. Or it's not handwriting will be way best. Good handwriting I will be having. But in this system, I am unable to write. Tomorrow I will put my efforts if it is possible. I will try to do better. Okay, in the next class. Okay. Thank you. Let us continue in the next class. Okay. Thank you. Right. Understand? Okay, okay, so okay, just. Okay, let us continue more 15 minutes. Then let us start the other topic actually. Next, Newton's laws of motion. Next chapter, Newton's laws of motion. Laws of motion. Let us continue. There are three Newton's laws of motion. Just before learning about Newton's laws of motion, let us learn about inertia. What is an inertia? Inertia. So just before learning about even inertia, let us learn let us speak about Newton. Newton is known as millennium scientist who gave the maximum inspiration to the modern world. Newton gave the maximum inspiration to the modern world. That's why he is known as the that's why he is known as millennium scientist. Why? Because in the year 2000, an online opinion poll was conducted. An online opinion poll was conducted. A maximum number of students and here participated in online opinion. So not only to the students, even scientists, doctors, engineers, professors, lecturers, teachers, students, research scholars, those who are interested in science and technology, they participated in online opinion poll. And they chose Newton as millennium scientist. Why? Because whenever Newton was at the age of 11, he was sitting under an apple tree. Then the apple separated from its branch, then started falling to the ground. Then he thought, why does it fall to the ground? Why does it fall to the ground? Why? Because then why does it fall to the ground? Why can't it stay there? Why can't it stay? Why does it fall to the ground? Then he thought. So then why can't it stay there or why can't it go up? Why is it falling to the ground? Then why did he think like that? Then why such a that much of crazy has come to his thought? If you think, suppose we are an astronaut, why did Newton thought like that? Why can't it stay? Everything will fall to the ground now. Then he thought reverse. Why can't it go up? Suppose we are an astronaut, let us go in a spaceship up to some thousands of kilometers. Let it be 4 or 5,000 kilometers of height. Let us stop our spacecraft. Now, let us take any object like stone, or let us take away any apple tree, which is consisting of an apple, or branch of the apple, which consists of an apple. And now separate the apple from its branch in the space, just leave it. Just separate, just slowly leave it. Gently you leave it. It remains there only. If we conduct the experiment here, it falls to the ground, but there it remains there only. It won't fall down. Whatever is happening here, it's not there. Whatever is happening there, it's not here. It is something different there than here. It's something different here than there. Therefore, that is different. Whatever it is happening there, it's not here. What is happening here is not there. So that's a problem. Whatever is happening there, it's not here. What is happening here, it's not there. So Newton got at the age of 11 such a doubt. So then let us draw here, project an object here. It goes up and then falls to the ground due to gravity. So, but there, if you project on the object, it never gets back. It goes on forever. That's it never gets back. If you look even for minutes, hours, days, also it never gets back. It goes on forever. Let us stand up on the top of the multi-story building. Let us project an object in horizontal direction. How does it go? It goes in parabolic path. Then what is the Path traced by the bullet released out of the pistol, it travels parabolic path. On the earth, it travels in parabolic path. It never traces straight path. Never trace. But there, Fanny, why? Because it comes due to gravity. Suppose we go to straight path, what happens? Suppose a person like us, like me, got a chance how to fire in the Olympics, the pistol. Suppose I know basics and fundamental science, I'm looking the straight forward and I push the trigger, it goes in. Suppose you go to straight line, what happens? It hits the target, but it won't hit. It goes in parabolic path. It goes in parabolic path like this. It goes in parabolic path. It never traces straight path. Never traces straight path like this. It travels in parabolic path. Travels in parabolic path like this. Like this. Travels in parabolic path. Never goes straight path. Never goes straight path. Therefore, but if there any object is projected like this, at 4 or 5,000 kilometers, it goes on forever. It goes in straight line. Why? Because according to Newton's first, whatever is happening there, it's not here. Or whatever is happening there, it's not here. Whatever is happening here, it's not there. It is something different there. Newton got it out at the age of 11, not like us. So therefore, he got it out. So Newton got it out at the age of 11. Then he conducted so many experiments during his life. So many experiments he has conducted. Then after becoming the graduate, he proposed the famous law called Newton's universal gravitational law. Newton's universal gravitational law. Therefore, according to which there is an attractive force between every two objects. Earth attracts any object. Earth has gravitational power. He found that after becoming a graduate, he proposed the famous law called Newton's universal gravitational law, according to which there is an attractive force between every two objects. And based on this only, nowadays the space technology developed. We are using today 4G technology, and as a part of which we are using social media, WhatsApp, Facebook, YouTube, Twitter, and Instagram, everything we are using. Also, internet we are able to use. Satellite communication system we are using. So, and internet we are using. This much of technology was developed, and the reason, the major person is Newton, according to the majority of the scientists. That's why Newton is known as millennium scientist. So there are three Newton's laws of motion. Just before learning about Newton's laws of motion, let us learn about the property called inertia. What is inertia? What is inertia? Inertia is nothing but unless no external force is acting on the object can't change its physical state. Unless no external force is acting on the object can't change its physical state. That property is known as inertia. That property is known as inertia. Inertia. That property is known as inertia. Unless no external force is acting on the object can't change its physical state. Then there are three physical states of the object. Physical states of the object. Physical states. The object. Number one, inertia of rest. Rest, motion, and direction are known as. First one is rest. Second one is motion. And third one is direction. These three are known as the three physical states of the object. Direction. These three are known as the three physical states. Therefore, unless no external force is acting on the object can't change its state. This property is known as inertia. And based on the three physical states of the object, therefore, inertia will be also three types. Inertia will be three types. Inertia will be three types. Inertia is three types. Three types. First one is, they are number one, inertia of rest. Inertia of rest. Second one, inertia of motion and inertia of direction. Second one is inertia of motion and inertia of direction. Of motion. And third one, inertia of direction. Of direction. These are the three kinds of inertia. Inertia of rest, inertia of motion, and inertia of direction. Then what is inertia of rest? Let us learn about inertia of rest. Unless no external force is acting on the object can't change its state of rest. Inertia of rest. This property is known as inertia of rest. Unless no external force is acting on the object can't change its state of rest. This property is known as inertia of rest. Unless no external force is acting on the object which is at rest remains in its position of rest. This property is known as inertia of rest. Suppose we are sitting in a, suppose a passenger is standing in a bus. Example number one. Example. Passenger is standing in a bus. When the bus suddenly moves forward, what about the body of the passenger? Leans back due to inertia of rest. Whenever bus stopped at a bus stop, if the passenger is standing in the bus suddenly moves forward, then the body of the passenger leans back. That is due to inertia of rest. What it is going on happening? Whenever the bus moves forward, why does the body of the passenger leans back? Just before thinking about it, why does the bus move forward? Is it moving forward itself or any external force is causing on the bus? Some external force is causing on the bus. But the external force, that is mechanical force. Bus is having an engine. That engine will apply some force. That force is called mechanical force. Due to mechanical force, the bus is brought up from rest into the motion. But since no external force is acting on the body of the passenger, before it was at rest, now it remains in position of rest. But whenever bus is moving forward, his body remains there only. Therefore, it leans back. But due to the frictional force between the base of the bus and his feet, only the feet will move forward. Since no external force is causing on the body of the passenger, his body remains in position of rest. Therefore, body remains in position of rest. Therefore, so this is known as inertia of rest. Unless no external force is acting on the body of the passenger, whatever it was at rest remains in position of rest. This property is known as inertia of rest. Okay. Now let us continue tomorrow. What is inertia of rest, motion, and direction? Let me continue next class. Okay. Thank you. And I will try to improve some handwriting. Just the system is like that. I will try to improve my handwriting if it is possible. Actually, my handwriting will be good, but here I am unable to write. If anything is there, I will try to rectify tomorrow. But whatever you see is just try to follow my voice. I will explain clearly so that you can understand better. I am faculty, senior faculty, working in so many institutes in Hyderabad. That is for exclusively civil services group, science and technology teaching, group 1, group 2, and sub-inspector, SSC, RRB also. I'm working in various institutes from past almost 20 years. Okay, thank you. See you. సార్ ఆపేనా సార్? ఆపేనా సార్? స్టాప్ షేరింగ్ ఏముంది సార్ ఇక్కడ? అది అన్న